Hi, welcome to another PHP 2 video. In this class, we're going to talk about database indexing. And so we'll explain some basic concepts and look at one of the requirements in the assignment we're working on right now. So if you look at activity 11, which we're creating right now, there is one line in here on line 4 that says, the weapons store must support from 500,000 to 1,000,000 different weapons. And so that's supposed to be a clue to you that we need to use indexing. So let's talk about what indexing is. So the purpose of using indexing in a database is to optimize your search performance. And so there are tools out there that will let you tell how long to the millisecond it takes and how many CPU cycles it takes to find the data that you're looking for. Think of an index in a book. That's the good analogy for how an index in a database works. So consider searching for a key term in the book. So you can see on the left example here, I have a Word document and I am using a full text search for the year 2015. And you've done this before. Control F on your keyboard and you can quickly find something on your web page. Well, in a book though, you have more than just a few pages. You might have thousands of pages. And if you are doing it manually, the index is your tool for finding things. So look at the example on the right. If you're looking for a constitutional Democrat, you can find it on page 71 and 74. Your search is done. In the old days, that would have taken you a long time to read up to page 71 to find it. So the index in a database is like the index in a book. So the book is printed in page order. You have to read it from page 1 to the end. However, your subject is in sorted order in the back in the index. And so intuitively, that's how an index in a database works as well. So there are trade-offs. Anytime in computer science, if you're doing something faster, it's going to take more space, or if you save space, it's going to go slower. And so in indexing, using more storage space will slow down your deletes and updates, but you will improve your search performance if you're doing a lot of select statements. And so it depends on the kind of application that you're building. A lot of applications do selects and searches, and so indexing is usually a good solution once your database gets to be very large. So think of another way of sorting items. Suppose you're an assistant in a legal office, and your job is basically to keep track of thousands of documents, and so when the court lawyer says, give me the paper on case number 5, you can go right to the folder and give him the paper that he's looking for. And sorting and putting things in tabbed folders is like indexing as well. So if you alphabetize all of your big documents and put them into folders, intuitively that's like 26 times faster for you whenever you need to go find something. So if you know that the case starts with the letter P, you go straight to the P folder and start searching, and you don't have to search through most of the alphabet. So your searches are much faster. Now, if we were to think of the indexing in a computer, there are really 3 types. So the single column index is the most common. So if you're doing a select on a database and you're looking for just one attribute, like in this case, the example of age, if you're using one attribute, then that's probably a single column index. So imagine you are in charge of all of the Social Security accounts in the United States. So all 300 million to 500 million records, and you want to find only the people that are age 50 and older. That's a perfect example of indexing. So if you sorted the list of users or people and you put them in alphabetical order, it would take a long time to find the people that are age 50 and older. However, if you resorted the database by age, then you can index on age and you can find the beginning number for 50 very quickly. So you don't have to search through all the children and the teenagers and young adults. You can jump straight to near the middle of the line or toward the end and find all the 50-year-olds. Now the composite search is a different kind. It uses 2 different columns. So it's useful if you're searching for like first name and last name put together, and you're looking for all the Smiths and then somebody named Bob, so it would sort by Smith Andrew, Smith Bob, Smith Charlie, Smith Dennis, and it would sort the Smiths first, and then secondly it would sort by the first name. There's also a unique index that you can create. So if you say in my index I don't want to have any duplicate items, it's similar to using the column ID in your table where there are no duplicate rows. By the way, most databases automatically index the ID column. So user ID is already in an indexed format, and it's just makes things faster for you. Here's a strategy for creating the index. It's called sparse indexing. And think back to the folder example. So if you were to make a sparse index of records here, you would create maybe one item out of every 100 and put it in your index. So for instance, if I were searching for the blue cups here, if I said give me item 7092, which is blue cups, you could look in your sparse index first, and you would look down and say, I'm going to search for 105, 205, and when you come to 7005, you can say, hey, I'm getting close, and then the pointer would show you the row number where the blue cups, where you can find them. So you could start searching at row 7005, and then very shortly you'd come to row 7092. So a sparse index is a strategy for building an index for you. So a lot of the times the computer will take care of what kind of index it is, so you might not need to know exactly how it's working behind the scenes. This example would show you approximately 100 times improvement in your search speed because the sparse index looks like it is using about one item out of every 100. If you were to use a multiple column index or a single column, you might think of searching for product name. So you can see that the table has now been reorganized. It is shuffled by product name. So it's sorted from the letter B all the way down to the letter T. And so if you said, give me napkins, you could start searching right there on row 5, it looks like, yeah. So the index order is important when it comes to finding alphabetized items as well as numbered items. So in computer science, they use different ways of finding items in an alphabetized list. B-tree is something that we'll look at in just a second. It's a very common way to find and sort items. By the way, if you are into sorting and searching and you take a class on algorithms and databases, you will find something that comes up all the time. It's B-tree or binary tree. So think of the game of guess a number. If you were to look at the tree on the right, I could tell you I have a collection of numbers between 1 and 13. Guess, which one is it? And you would probably start somewhere between 7 and 8. You'd say pick a number in the middle. And if you said 8 and I said no, too low, you have to guess higher, then you would say, hey, how about 10? And I'd say no, still higher. And you say 14. I say you got it. So if you get 14 on 2 guesses, that's pretty fast. However, if you were to do a sequential search and you said, is it number 1? Nope. Is it 2? No. Is it 3? No. And so on. It would take you 14 queries or 14 questions to see if you're getting to the number 14. And so the binary search tree is a very cool method for making searches go quickly. And so you will learn more about search algorithms and binary trees when you take the class called Data Structures. Here at Grand Canyon University, it is in Computer Science and Programming as CST 201. And if you're anxious to see what this looks like, just go to Google and search for B-trees, binary trees. You could also search for quick sort, heap sort, or bubble sort, and you'll find all the information out there that you'll learn in this class called Data Structures and Algorithms. However, most of the time you don't have to worry about how it's doing the work. People that design the databases are doing this for you. But here are some common rules that a programmer should have to keep in mind. When do I create an index? So if you are using a lot of searching, and you're searching for, let's say, a name, then consider using the index on that column. For instance, in this one, this example pops up here and it says we're searching for people who are older 50. So index the age column and your searches will go faster. So that's a good candidate for in this index. Indexing apparently is especially good if you're not retrieving many rows. So less than 15% of the results are actual ones that you want. That's probably a good candidate for an indexed column. You can also just tell from experience that when your app starts to slow down and the more data you put into the program, the worse the performance is, then it's time to think about indexing. That's the easiest way to improve your database performance. Look at what you're searching for and tell yourself, I need to go and see if I'm indexing on the right columns. So composite searches will work well if you have AND selects. So here's a SQL statement for when I create a table. Notice the last line in it says index name, and I'm using last name comma first name. So if I were to use that index in searches, I would look at this list and think these are good candidates for using this index. So you can see that I'm using the where clause, where last name equals. And then the next line says where last name equals and the first name equals. And the next one starts with last name. So all of these searches begin with the where clause, and the first item in the list is last name. So all of those will benefit from this index that I created. However, if I use first name and then last name, I put the order reversed, or I use an OR statement, then the computer will not use the index, and you'll have the standard performance from regular line-by-line searching. So if you also have join statements, that's a good rule of thumb for when you should use an index. So if you're selecting orders and customer IDs, notice the join, the inner join command. And as a default, your customer ID and your product IDs, anything with an ID in it, is automatically an indexed column. So usually you don't have to worry about creating indexes that will help join statements, unless of course you're joining on something besides the ID. Lastly, let's take a look at how you set an index. So in my database that I have in front of me, let's say I want to look at the products table, and I think that I'm searching for product name a lot. So let's go into the products table and look at the details. So I have the column names all listed here. Let's say that I search for the description, or I search for this column here, the product name. Product name would work better. By the way, the text field data type does not work well with indexing, but varchar does. So that's just something you'll find in the MySQL documentation. So let's say I'm searching on product name a lot. Let's go to indexes. You can see I have a primary index, and it is checkmarked to be on the ID column. However, I'm going to make another one. So let's say this is the product name index, and the type is an index. Let's go search over here. I check product name, and the order, I can say I want to search it in order. And I close the table. And so you can see down at the bottom of my list here, I have a primary index, and also I have the product name index. And so that is as simple as it is. Notice also here in the indexes, if I were to go look at the product name index and choose storage type, I have this item called btree. And so that should ring a bell from the PowerPoint slides I showed you just a few minutes ago. And so the important thing is get the index turned on for the columns that you use a lot and you do a lot of searching for. Just one final note as we quit here. There is a trade-off. So if you are indexing too much, you actually might slow down your performance. Indexing only works well for searches. If you are doing a lot of updates or deletes on your data, you constantly have to keep recreating your indexes, which will cause your computer to run slower. And so use indexes only if you have a lot of reading going on, and not so much with writing and deleting and edits. So in your final project here, when we have the weapons store has different types of weapons up to 1 million, that sounds like we need to have an index on the weapon description. And so let's see what we can do when we create our final design here for the weapons store.